Hello friends, today we will see the implementation of k-means in Python. So in this particular assignment, first of all we are going to import some packages. The import pandas as PD for data frame, import numpy as np for numerical or mathematical calculations, and matplotlib library for performing or visualizing our data set. Okay. So first of all, we have created one data frame with x and y coordinate, df data frame, and now as we know in k-means clustering algorithm, first we have to say the number of clusters that we can form. So here we are taking clusters k is equals to 3, and we are going to set the seed to some random number in order to reproduce the same results at any time. So for that we are setting the seed to some random number. Here it is 200. And the first step, after deciding how many clusters we want to form out of our given data set or a data frame, now we have to select k random centroids or exemplars. So here in this case we are selecting 3 centroids. So np.random.ranginit 0 to 80, the range is 0 to 80, and similarly for this range is for x and this range is for y coordinate. Why I am selecting this range? Because my minimum value is 12 in case of x and maximum value is in 70s. So at the max 0 to 80, so I am selecting the range at 0 to 80. Same for y also. And for I in range k, so this will find 3 random centroids for our given data set. So let us print this random centroids. So execute this. So simply it will find out the centroids, and here I have already executed. So centroid, just click on it. So it will give us centroid. So these are the centroids. First centroid is 2616, second centroid is 6842, and third centroid is 55 and 76. The next step is what? Now we have selected 3 random centroids. Now we are going to plot these centroids with our data set. So here we are just using figure plt.figure size. So we are setting the dimension for our figure plot, that is 5,5, and plt.scatter. So we are plotting the scatter plot of our data frame df, which has x and y coordinates. So df x and df y, and color is equals to k. Now in order to color to our centroids, in order to show these are the 3 different centroids, we are giving different colors to our centroids. So for that we are using a color map list, where 1 is going to have a red color. If centroid is 1, it will be a red. If it is 2, it will be a green, and if it is 3, it will be a blue. So we have one list that is known as col map, or we can call it as a color map. So for that we have mapped every color with one centroid. So for I in centroid.keys, so there are 3 keys or 3 centroids, so this loop will run for 3 iterations. And plt.scatter centroids of I means what? For respective centroid I am mapping a color. So for centroid 1 it will be a color map of I, that will be a color is 1, that is red. For centroid 2 color will be green. For centroid 3 color will be blue, so on and so forth. And plt plot x limit 0 to 80, that is the maximum limit you can find here in y axis and x axis, as the max limit 0 to 80, max and min limit 0 to 80. Okay, so this is what it will plot the centroids with the given data points. The next step, in after selecting the 3 random centroids, now we are going to allocate every data point. First of all, we are going to calculate the Euclidean distance from every centroid to every data point in a given data set, and whichever is a closer, that centroid will have that data point in its cluster. So here we are finding the, so we are defining one function, diff assignment, and we are passing the data frame and centroids. So for I in centroid.keys, so it will run for 3 iterations, and for every data point. So data frame distance from, I am calculating distance from format of I means what? The centroid. So it will calculate the centroid's distance from each and every data point, for each and every data point. So here we will get, this is the formula for our Euclidean distance, square root of x minus y whole square plus x1 minus x2 whole square plus y1 minus y2 whole square. Same formula is applied here. And after that, centroid underscore distance columns is equals to distance from. So we are forming one list where we are going to have the distance of each and every point from every centroid. So distance from centroid 1, so format of I indicates, the I value indicates the centroid for I in centroid dot keys. So there are 3 keys. For every key it will run for all the data sets. So after that forming, now after getting that, we are getting the distance from each and every data point for every instance. So here you can see for first data point, so 12 and 39, distance from cluster 1 is 26.925. Distance from cluster 2 is this much. Distance from cluster 3 is this much. So this particular list will form that distance from every other cluster. Then now we are going to find out the closest cluster. So df.loc. So here we are selecting a list. Now here it means colon means all the rows and the column centroid distance calls. So centroid distance call has distance from every centroid. Dot id dot x mean axis is equals to 1. Here axis is equals to 1 means the column, and id dot x means what? Minimum value from that column. Minimum value from that column. So df closest is equals to, so it will, what it will do, it will select the minimum value from that. So here which one is minimum of these 3? For first data point, the 26.92, 56 and 56. So minimum is 26, the closest distance is minimum. So for every data point it will find out the minimum value for every centroid. Okay, so that is the x mean. Then now df.closest, we are going to select which is the closest centroid to our data set or data point. So df.closest.map lambda x in x.lstrip. Now here we have selected this particular data frame for first data point is closest. So we are having in our data frame as distance underscore from underscore 1. So we want the closest. Now this indicates 1 indicates it is a centroid 1. So we are going to strip this particular string. So we are using here lstrip. So let's strip what? Distance from. So we are stripping out that, we are clearing that particular string, and we are keeping only the digit that indicates it is a centroid 1. Okay, and we do it for each and every. So here we will get the closest centroid is 1. It's 1. Here also it is 1. Here also it is 1. And here it is 3. And here in this function closest df closest dot map lambda x to call map x. So call map we have used colors. So here it will map. If it is 1 it will be a red. If it is 1 it will be red. If it is 3 it will be a blue. That we have already seen. So it will map every data point with its color. And finally we'll just, after assignment stage, we'll just print this and we'll execute this and we'll get this output. So here all these data points are being allocated to their centroids. Now after getting these centroids, now we are selecting all the data points, distance of each and every data point from their centroids. We are summing them and we are finding the mean of that. So once we are finding the mean, that mean is now new centroid. So for every cluster we are finding the mean. So for that there will be an update stage. So in update stage, I in centroid.keys, so it will run for 3 loops, 3 iterations. So centroid of I by 0 is np dot mean of df dot closest. So all the closest points mean, okay, we are going to find out, and similarly y coordinate and x coordinate for every centroid. Now after updating a centroid, if centroids are get changed, or means due to different due to cluster data points, we get a mean value which is different from whatever centroid was there. So distances of every point from the centroid is obviously going to get changed. So again we are going to follow the same step. So this is the final step. So we are going to do this unless and until there is a convergence. Once it is converged, we can say that clusters are formed. So here closest under centroids, closest dot copy. So we are copying the first centroid, previous centroids, and here we are using this update function, we are updating our centroids, and using the df assignment we are assigning. So whatever steps we are saying, we are just calling these functions from here in the while loop. And if closest underscore centroid dot equals df closest, so df closest is a previous centroid data set. So if it is having same data set, means there is no change in the centroids and our algorithm is converged, so we can say that clusters are formed, and we execute this. So simply we plot this graph and we'll finally get this output, and this is what the k-means clustering algorithm. Thanks for watching.